My name is Brian Venn. I own a test and balance and commissioning company in upstate New York, and we work all over the place doing anything from fire life safety, commissioning, tab disciplines to ASHRAE 110 testing. So I'm going to try to take you guys through what is probably the best practices or ways that test and balance companies can actually get better results out in the field based on some better practices both from the commissioning side and the engineering design side. And some of the stuff that we look for when we get out into projects and we start to have troubles with pumps and fans, how do we troubleshoot them and what is important to us and what do we need to troubleshoot those systems to try to get the engineering community some answers on the projects that they're working on. First, everybody's going to get some credit here on the course. So I just want to move through that. So what we're going to try to do today is look at some of the proper use, application, and limitations of tab instruments. We're going to understand what is accurate, useful, and meaningful data. Meaningful data to me is repeatable data. Because if I can't repeat it, what does it really mean? It's only a window in time. Useful and meaning data obtained in the field versus laboratory. We all know that AMCA tests fans, right, in perfect laboratory conditions, but in the real world, we have elbows and turns and all kinds of stuff that are not necessarily there for laboratory data. Gain an understanding of HVAC systems and tab measurement process, and how can systems be set up to allow for proper data collection. And we want to promote a team project approach to address schedule changes, design alternatives, as it relates to balancing devices and locations. It's always better to come in as a team effort, especially when there's trouble brewing on certain pieces of equipment, rather than go into jobs and start pointing fingers. It's always better to take a team approach. The results, I guarantee you, are always better. I'm sorry. There we go. So now we've got to our cover letter here. Some of the things that I want to look at is specifically, these are going to be all the things that we look at: specification issues, fan curves, traverse locations, or alternatives. You guys would be, I don't know, some of you may be really surprised at how hard it is to get an accurate, repeatable traverse sometimes, whether it's because of obstructions or elbows up or downstream of where we're taking our traverse. But there's a lot of alternatives to a straight duct traverse. We're going to talk about that. We're going to get a little bit into system effect. And then we're going to talk about pump curves, pump flow measurement, equipment considerations, and then the project issues, which every project has. I've been in this business about 20 years. I have yet to be on a perfect project. I'm still waiting for that cupcake. And when it comes to specifications, the documents need to indicate that hopefully that there's some independence there. AABC, certified tab agency, if they're performing the work, you know that they have no ties to any other mechanicals. They're not selling filters, they're not installing ductwork or pumps. And there's an inherent bias in that for companies possibly that are installing it and performing the balance, and now even performing some commissioning, as some of these firms are starting to do. The specification should also clearly define systems that we want to get balanced. We got to avoid gray areas, like when you're coming into a hospital and we're only renovating maybe 1 or 2 suites, and we're only touching 10 or 12 outlets off of a 500 outlet system. What are we really balancing there? And then does the owner actually know what the implications are for when we start to balance this system in these new suites, and what's going to happen to the rest of the system as we rob Peter to pay Paul, possibly? So it's really important that when we get to a job, there are no gray notes like in the top of the drawing that says you will rebalance the entire system. And this could be a 9-floor air handling unit, and we're only touching 1 soiled utility suite and a corridor off of it. So it's very important that we get those the specific, clear definition of what systems we're actually going to be working on, as well as tolerances. One of the other things that is always a hang-up is, right nowadays it's very popular to have a 5% plus or minus tolerance. Well, a lot of the times, the engineers and the people that are actually approving the submittal or the equipment, they're not necessarily always looking at what the capabilities of the equipment is. In some cases, VAV boxes have a plus or minus rate of 14%. Well, if that's the case, there's no way that as a balancer I'm ever going to be able to get a plus or minus 5% balance at the outlets. So that's just one detail or one example of what we're hoping to see when we get there, and to hopefully get a balanceable project and not come up with 3 or 4 issues before we have even finished our balancing plan or procedure. We need this, and this is where I was going. The spec needs to clearly define the scope of work pertaining to the systems. So again, if we're only balancing an area that has very limited VAVs or no VAVs at all, it's constant volume, a good balancer should come back to you guys and ask the question, what are we going to do with the rest of the system? Because along the line, maybe it just got dropped or somebody wasn't thinking that this is connected to another system. As commissioning agents and engineers, you guys should learn to expect, especially from AABC companies, that we ask these types of questions. These are the meaningful questions before the rubber hits the road. Sometimes it's hard to react once we're at a job and then we have to adjust our path or adjust the schedule because we didn't know that there was another 100 outlets that maybe the owner thought was getting balanced as well, but it wasn't included in the spec to the GC or the mechanical. And there's those types of communication gaps that it's really important for the tab firm to come in and fill, in my opinion. Try to think of how data will be obtained and what data will be required before specifying the requirements. Are we going to be able to go out and take a traverse and be able to repeat that reading at the same speed of the fan, the same RPM, same hertz? There's a lot of times where when we go out there and we perform a lot of tests and we're gathering temperatures and we're gathering pressures and we bring all this back to the table for the commissioning meeting, and sometimes they only touch on a couple of things, maybe the outside air change rate, maybe they're looking at the fan speed or the brake horsepower, and they've had us collect all this other data that may or may not be meaningful, and it may have just bumped up the cost of the project. So being able to really define what you want to see out of the data that you're actually having us go out and collect is really important because it allows us to really get in and drill down to the detail that you guys are looking for versus us going out and trying to perform a total system balance when only you guys were looking for a few little pieces of data, relative humidity or some issues that you guys were looking for on the trouble, on the issue or the troubleshooting we may be doing. Again, the 5% tolerance is there. I got ahead of myself. That one drives me nuts. It's very hard to attain, and again, that also can add time to the project. For tab firms that are actually out there doing the work, we have to make 2 or 3, possibly 4 passes before we can go through the entire system and try to read every outlet at 5%. Because inherently, as we're pushing air around, that 1% could be 1 or 2 CFM in a closet somewhere, and now we can no longer reach that 5% spec because in some cases, our instruments, even the manometers that we're using, you have to look at the tolerance levels and the repeatability of those. And some of them will actually go against what is in the design as far as the tolerances of the equipment that we're actually using. VAVs in this case that can wander 14% either way. Reserve tight tolerances for special applications, not creature comfort issues. If we're doing a chip plant, obviously we need to really have a very tight, stringent tolerance level. But if we're doing an office building, you could probably be very pleased with what the outcome is of a plus or minus 10% balance. The 5% really just adds time and effort to the process, and it could actually end up holding up the balancing report. If we can't get a couple of the rooms to that 5% tolerance level, then what happens? We're all in meetings and we're all talking about acceptance and what we're willing to accept and what we're not. And if we avoid the 5% tolerances, some of those meetings we can all avoid and get hours back in our day. And again, the tab equipment manufacturer tolerance exceeds the specification. And I've had a lot of experience with Shortridge, Alnor, Evergreen. I've used the whole gamut. I'm not going to recommend one over the other, but they all have very specific tolerances levels. And as you guys are out doing commissioning and you're watching the different instruments that people are using, it doesn't hurt to look at what the calibration date, first off, of your equipment, but also what are the tolerance levels of the equipment that they're using to balance. Okay? Coordination. This is everybody's bane of existence, I think, as we try to get the sheet metal, insulation, pipe fitters all on the same page and all on the same milestones. I don't know about you guys, every project I'm on has a very beautiful Gantt chart that shows all the milestones and not everybody's going to hit them, right? And there's no pushback when things get delayed. Or anybody get a pushback? If something gets delayed, do you get to move out your date? I don't see any hands. Okay. That's pretty normal. So we all know that those charts are about worth as much as the paper they're printed on. And then it's up to us as the construction team to figure out with all the hurdles and all the roadblocks, how to get the coordination right to still hit that date so the owner can occupy the building and get it into service, right? They want to start billing for their time in that building, especially if in the hospital and the healthcare community, they want to start doing procedures and operations immediately, if not beforehand. So there's always that crunch time at the end. Installation specification requires that and this is something that comes up, so this is why we wanted to put this in there. On the water side of tab, we always see the insulators insulate over the valves. And then it's up to us to either cut and break the vapor barrier, which we don't want to do because we're not insulators and we don't carry the tapes and the extra insulation with us. So it's important to catch in the spec what you guys are expecting other contractors to do to make the tab go at least, I don't want to say easy, but at least be applicable to the job. If I have to start cutting insulation everywhere, that's going to lead to a whole bunch of ramifications down the road to who owns repairing the insulation, whose responsibility was it to not insulate over, and it just starts to become a real push and shove match. If we can spell it out in the specification that all water test ports are accessible, all balancing dampers handles are exposed and visible. We even have a lot of the mechanical contractors in our area hang little white pieces of tape or warning tape from the handles so that if we pop a couple of tiles, I can see how many tiles across the ceiling that damper is. And I don't have to go through and touch 6 or 7 tiles, and then we have to maybe, we wear gloves, but if we don't, some of the tiles get dirty, and guess what? Everybody starts getting back charged. So if we can have ways for the contractors in front of us to help facilitate the balancing, and this is usually handled in a kickoff meeting. The mechanical guys are already there. They've had a presence for months and months. The earlier that you can get the kickoff meeting and get the tab contractor on site to go over what he hopes to see, the better result you're going to get, because then the mechanical can get out in front of it, start hanging dampers as they install them, or start marking ceiling tiles. A lot of hospitals now, because they don't want us touching ceiling tiles, and we have to use what I call the phone booth so that we contain the whatever may be in the ceiling, depending on the hospital. Now that's adding time to the operation. So if I could pop one ceiling tile and I can look over 3 more ceiling tiles and I see the string hanging off the damper, my life just got a lot easier and we're moving through and hitting our deadlines a lot faster. Water flow measuring stations need to be complete, accessible, or need complete access from installation to verify sizes and models. One of the things that they try to do is they'll cover up the valve, but they'll leave the handle exposed so you can just see the handle. Well, that doesn't help me because I still have to cut out the ports. So beyond not being able to see, to verify sizes and model tags, the tags sent with the flow measuring stations, they may need to be used for verification. Maybe they contain the design drop on that, and we need to find that on the handle or on the body of the valve. I know that FDI valves, they come with a little sticker on their handle, and they say you will have a 14-inch pressure drop at 6 GPM, depending on what the size of the valve is. So we need to access the body of the valve. And I know that the insulators are trying to do a good job and cover up and make as much of a vapor barrier as possible, but there are certain things on flow measuring stations especially that we need to have access to those bodies, especially auto balancing valves, which is a big fad. And as a balancer, I like automatic flow measuring devices and balancing valves. Some of them, I don't like when the manufacturers say that it's auto balancing, because we still need to go out there. We need to verify that the spring or the valve internally is actually the right size, because the factories never send out anything wrong, right? Everything's correct when you get there. So there's a lot of times where we need to be able to go in, and even if it's an automatic balancing valve, we need to troubleshoot what's going on and make sure that the internal parts are correct from the factory. So even auto balancing valves, which are our friend, we still do need to balance. Control specification requires that access to the control system is made available for the tab agency. As commissioners, imagine how hard your job would be if the control guys did not give you a path to look at their stuff, right? It would be impossible to do your job. The same applies for tab firms. I can't do anything on my checklists or do any of my tab procedures unless I know and understand a way to access the computer and actually exercise the equipment. So it helps us, because what will happen is a lot of control contractors will say, well, we'll supply them with a laptop or whatever, but they have to pay $6,000 for the proprietary software. I can tell you right now, I'm never going to buy control software. I am not in the control software business. I know how to use it, but it's not going to help me get my day-to-day job done. So why would I buy that for every job? I would just probably try to pass that cost off to the customer. That increases the cost of the job. Nobody wants to do that. So one of the most important things we could do is, as the engineering community, spell out in the specification that the control guy will give X, Y, and Z so that the tab firm can do their work. And if we don't have that ability, we can still sometimes get our work done, but it's going to take a lot longer, and it's not as transparent as if we're logging into the BAS system and actually exercising it like the facility guys are going to be doing after we all leave, right? Shiv changes are not automatically responsibility of the mechanical contractor or the tab agency. We're relying on the fan manufacturers who have all this great software, and they extrapolate all these numbers, and they have all these different model numbers of fans, that when it comes out of that factory, they're claiming that they did it right, and they have this packaged rooftop unit that it's always going to do 5,000 CFM at 3/4 of an inch of static, right? And that's great because they tested that in a laboratory with great straight duct. That doesn't happen in the real world. So part of the reason that we don't want to get into the shift changes is we never know what that's going to be. Are we going to have to, on a school, let's say, with 20 typical rooftop units and exhaust fans to match, we can't price that at the beginning of how many shift changes we think we're going to have to do. We would never get the job if we had to do it that way. So it's really important that it's spelled out in the specification. And it is difficult to define who is responsible. Is it the manufacturer? Is it the contractor? Is it the engineer? In my opinion, it's the fan manufacturer, because they have all of these years of data built up that shows them what their package unit is going to do based on a given pressure drop and a given external static. So it's really hard for me, it's hard to hold anybody on the construction team responsible for unknown shift changes. And if that's spelled out in the beginning, that it comes from the factory wrong, and any work that needs to be done in the field to make that unit compliant or within tolerance, that's going to go back to the factory, unfortunately. And they needed to do a better look at their shift ratio before they sent that out. Shift changes for fans should be included as an allowance in the project or handled as a cost plus change order. This is a way of getting out in front of the problem. In a lot of the tab firms, if they have a lot of experience with this, during the bid process, they should be asking this question. If there's going to be shift changes, how should we handle it? So that we know going into our bid, how would you guys like to see that number? And if the GC already knows that's going to happen, sometimes they'll set a little generous pool of money aside, $3,000, $4,000. It's not an astronomical number, depending on the job size. But on a typical school that I kind of outlined earlier, I mean, it's not uncommon for us to have $3,000 to $5,000 in changes for shivs if we're working on 100 supply and exhaust units across different rooftops of a school. Especially when one fan is typically selected for multiple uses on a school, right? You'll maybe put the same fan on a laboratory hood that does 1,000 CFM, and that's got less of a duct drop than the bathroom exhaust system that may also have the same fan and model number on it, but they have different static drops externally. And that's something that the factory is never looking into. But it's something that people who are doing the planning and the design reviews, that's something that we should all consider and take into consideration of what the impact could possibly be. And having a cost plus change order, it really just kind of protects the GC from surprises, and it protects the contractors from being responsible for items that maybe it's not right to put at their feet. Avoid catch-all clauses. I touched on this earlier, and this is that gray note area where we're working on a hospital and we're doing 4 stories or 4 floors of it, but the system actually serves 8. And the catch-all clause, I've seen more than one occasion, and I always ask the question and send it back to the person requesting the bid for is, what is this "you will balance all outlets" mean? Does that mean all outlets shown on this drawing? Or is the engineer getting tricky and he wants to get the whole system rebalanced with a very small catch-all note? Anybody else have any experience with that? No? Yeah, I saw a couple. I know it's a tab guy. So really, when you're going into building these drawings and prints, you want to be able to avoid a catch-all clause because it just doesn't define the work. It goes back to defining and clearly defining the scope at the beginning of the job that you would like done. So do clearly show the requirements for balancing valves, dampers, and or test ports on the plans and details. A detail is a balancer's best friend. Because if I have a really good detail about a branch takeoff, for instance, that shows a quadrant damper with a standoff and a locking nut on it, when I get to that damper, I know exactly what to expect. If there's no detail on the job and I start to get out there and we're getting into 6-inch rounds and I start finding 1/4-inch volume dampers, that's a problem, right? They're not reliable. I can't really lock them. If the unit turns on and there's a hard start, those dampers can actually flop and move. Not to mention, you can move the handle on a 1/4-inch, those little 1/4-inch dampers, and the damper doesn't move. So if we have a detail when we get out there and I start to see these 1/4-inch dampers and I look at a detail that shows a way different damper as an expectation, now I can call that stuff out. If there's no detail there, there's no way for me to call it out. It said a volume damper, it showed a line with a handle on the drawing, and that's as far as it went. That's not really good. And that also kind of goes back to, hopefully the owners are calling some of that stuff out too, if there's anybody on the owner's team that may be looking at that. As far as serviceability after the construction phase is over. Remember that furnishing and installing dampers and valves is not the responsibility of the tab agency, especially an AABC firm. We are not in the business to install pipe. We're not in the business to put dampers in. If we're there, will we connect the flex and try to fix something if it's within our power? Absolutely. And you should expect that from your contractors. But we're not there to fix the deficiencies that were left out by the mechanicals who were rushing through and forgot dampers and et cetera. So it's really important to not really put that at the tab contractor's feet if there's dampers and valves missing, because again, especially AABC firms, we want to maintain independence, and if we start installing valves and something could go wrong with the valve, there becomes a bias there, and it's really just not a good setup. Specification issues. So the first thing is calibrations of instruments. A lot of manufacturers will mandate that you want to get your manometers, hydronic or air, you want to get those calibrated every 2 years. I personally, we've got 25 guys out in the field. I do every single one of their air and water meters every year. I don't want to fall back on that 2 years and find out 18 months into it that one of my meters was way out of whack. Because then I'm thinking to myself, I need to go back and figure out where that meter was, and do I need to go back and do some QA/QC on it. So I just accept it and I send my stuff out every year, and it's just a practice. I think a lot of the AABC firms that you're going to come across are doing the same thing. Identify each VAV box, fans, AHUs, horsepower, etc. Yes, with a separate identification number, or heat pumps, excuse me. So a lot of the times we'll come into a project, they're doing a brand new build, they're putting a brand new air handler on a new extension to a building, and they're calling it AHU1. Well, there's already an AHU1 in the building somewhere, so now the BAS system has 2 AHU1s, the alarm starts going off for AHU1, the facility guy is just pulling the printer paper out, right, figuring out where he has to go that day, and he sees AHU1. Well, in some cases, I've been on hospitals, I'll keep them nameless, they had 16 AHU1s. Every time they did a new addition, they put a new air handler 1 on there. And finally we got in and we got some organization going and some renaming, but it was kind of shocking to sit in a multi-million-dollar hospital with lots of things going on, and they didn't really have a way to track which AHU1 was which, because everything was AHU1. Same with VAVs. A big problem with VAVs is in the schedule, they'll call out a VAV that has a min and max of 500 and 1,000 CFM on it, and they'll call that one VAV1. Well, there's 30 of them. That doesn't help us. Then we got to start looking at what room number is, what air handler is it served off, and we actually, as tab guys, we have to make our own nomenclature on our reports. Otherwise, our report is just going to show VAV1 everywhere, and you guys are all going to be like, what is this? Clarification on testing of domestic water. This is something new, and actually AABC just came out with a standard for testing domestic water. Personally, on my end, we do it with an ultrasonic meter. I do not like the liability of plugging any of my meters in, even if I've cleaned them, to any potable water systems. It's just an inherent risk. I would advise anybody against it personally. But there is a new standard that will allow us to go through, clean our meters, and actually plug into the probes if we need to. I think it will fall on each tab agency's lap on what type of risk they want to inherit if they're going to start plugging into those potable water systems. But this has been a big thing for us personally. Until about 2 or 3 years ago, we barely touched these. Now we've gone out and we've bought 6 ultrasonic meters because we do so many of these systems that we are always having our ultrasonics out in the field being used. So we had to get a few more. Consider installing temperature sensors on the domestic hot water recirc loop that can report back to the DDC system. Energy, right? This is why we're here. And one of the biggest losses in energy is heating up water and it either not being used or we're heating it up and it's sitting, and we need to be able to watch what's going on in the recirc loop, and that will allow us to really tune in how much we're putting into energy-wise to keep a certain temperature, or even analyzing what temperature would be appropriate. A lot of the places, they have really high temperature with water coming out, and in my experience, sometimes we could lower that down a couple of degrees and maybe eke out a little more savings. And you guys should look for not only the BASF, but you guys should look for your tab contractors to add value there, and there should be suggestions over the course of the project. If a tab agent comes in and they don't talk to you about domestic water, or they don't ask questions about VAVs or nomenclatures, and they just show up at meetings, start hitting them with questions, really. Because we should have 20 questions, especially at our first meeting, from anything like what milestones are still applicable on that Gantt chart that we saw 6 months ago, to where the buildings stand right now. So being able to have that feedback from your trusted tab agency is very important, and it's becoming more prevalent in the domestic water as well. Fire pumps. If these are systems that cannot maintain an established water flow, then the water cannot be measured. So I do a lot of work in the city, in New York City that is, and they all have fire sprinkler systems. Some of them have fire sprinkler systems, I should say. And we always get tasked with going in and trying to tell them how much water is going through, and they always are shocked when I say, well, which one of the heads are we going to open up? Because how else would we really be able to test the system unless we start opening it and seeing what those pumps are going to do? All right? And believe it or not, a lot of people kind of miss that in the planning. It's something that gets missed a lot. Specification issues. Duct leakage testing needs to be coordinated in the specification. Who does it? How many tests are required? And most importantly, what standard are we testing it to? Is it SMACNA? Anybody know? That's the question, right? Whenever I get into the GC I say, all right, we're going to do it to the SMACNA standard. This job is doing all the other installation per the SMACNA standard, and then they turn the table on us and go, oh no, we don't want that. We want a 1% leakage. Well, your class and your ceiling that you specified for the ductwork isn't going to handle a 1%, right? And they have an unrealistic expectation of what we are able to do and what we're able to accomplish with that duct leakage test. Now, it's very valuable. I would never discredit not doing duct leakage. It's one of the most important aspects of it, but it's very important for the specification to outline what procedure we are to follow, whether it's a SMACNA procedure or if it's something specific to that maybe engineer or maybe that client. But it's really important that it's spelled out what standard we should follow. Sound and vibration should be specified for what sound and vibration is actually required. Are we looking to determine the NC chart of an office, or are we looking to diagnose a sound that's coming from the ceiling and we're trying to pinpoint, is that a light or is it a vibration that we're picking up? And we do that based on what the specification calls out. And in the troubleshooting role, it obviously becomes a little bit more cloudy, and we have to really dig into where that sound is coming from. But it's important that we understand the specification, because we may get out there and we start testing and doing some sound testing, and we're picking up information. Again, that may not be pertinent to the team? Is it measurable and is it important? Why are we going to get that data? So letting us know what we need to do in our sound and vibration is very important in the specification. Now we're getting to the fun part, and I've had the opportunity to take the tour at a couple of different facilities from Train and some others to be able to see how fans are made and see how fans are tested. And it's eye-opening what you see, these laboratory conditions, because they're beautiful. There's always a free inlet, there's always a straight discharge, we've always got a great ideal traverse plane with no editing and perfect air heading down the stream. Multiple speeds for extrapolated data. So a lot of the fan manufacturers will test it at one speed at a given CFM, and they'll extrapolate the rest of that information. So is that real data, or it depends on how you feel about that. But extrapolated data is included in a lot of fan curves. Standard temperatures and pressure, and normal manufacturing tolerances. That goes back into like tip speed. When we start to have to increase fans, we find them deficient in the field. We got to speed them up. We're limited by brake horsepower and tip speed of the fan. The last thing we want to do is speed a fan up that could actually fly apart because the welds are not rated for that speed. So it's really important to know what is going into that fan curve and how they found it. And knowing the limitation of the fan curve is super important. As a tab guy, I don't want to own any fans. A couple of my guys have drilled into coils, so I have some coils in the office that are really great pieces that I talk to people about, but I don't want to own any fans. So I always tell my guy, when you're speeding something up, they just know to look at brake horsepower, but the last question I ask them is, what's the tip speed of that fan? ASHRAE puts out a great article. You can find it in their journal back in 2005, and sparing you some of the minutiae of this because I want you guys to stay awake this afternoon. It basically gets into fan curves and being able to look at what you see and what you get, and looking at how the fan extrapolated curve actually looks versus the operational curve that we're establishing once we get out in the field. So if you guys wanted to find this is a really good article that ASHRAE put out about fan data and gathering it and what it really means. Traverse location. This is a really good one because everybody thinks that the balancers can just go out there and we can get a volumetric total reading on a fan at any given moment. And that's really just not always available. We all know that architects do not like mechanical rooms. Does anybody know an architect that likes a mechanical room? No? So we're always left with a really small space, right, to pack all these body components, I call them, for the building, because the fans and the pumps, they're just the circulatory system of the building. So if I can go in and try to find an ideal traverse point, that's great. But most of the times in these mechanical rooms, the ductwork comes off the discharge and it immediately elbows down and goes through the floor, or it goes up through the ceiling, and we don't have a straight run of duct to establish that flow consistently down the ductwork. It can result in many things. One of them is eddying. And if we start to do a traverse and any of our readings are more than 15% off of the average, technically we're supposed to throw that reading out. Now, as an experienced tab guy, that would almost disqualify almost all my traverses, because there's always an eddy somewhere or there's a phantom reading in there. So it's really important to understand how did the guys go out and get it in the field, and is that the right place for the traverse? Or did they just drill the first spot that they found? A lot of the times, you can get a full reading on the outside air system. When we can't get a full traverse downstream, we can flip the air handle over to 100% outside air and read the outside air louver on the outside. That's one way. Obviously, it's a lower static drop through the unit than having the return duct associated with that, but it's a way to get and at least establish a volume for what's going through that fan. Another way to do it is to traverse the coils. If we can actually get inside the unit, we can actually do a Velgrid traverse of a cooling or a heating coil, and that'll also give us a total flow going through the unit. So those are two examples of how to establish or get a traverse even in the absence of straight duct. Here's just some math and some alternatives to traversing, face velocity readings of the filters, coil, possibly the hood face. We can also, if we have to, use a summation of the outlets. But again, that's taking into consideration all the loss in the system. So you have to know you're moving more air back at the fan than what's actually coming at the summation of the outlets. And then what is the summation of the calibrated VAV boxes? Obviously, this has occurred after the VAVs have been calibrated and checked out. But you can go in, and if you have them all set up at max, you're simulating a full cooling load on the building, you can look at what all the VAVs are doing in the absence of a traverse and hopefully back into what the total flow of the fan is if we can't achieve that reading for you. So if a test and balance guy comes out there and his report does not show a number on the traverse and a note, but you guys are walking in the unit and it's a large enough unit that we could get in there and traverse, call them out on that. Tell them you expect that reading because that's an important part of the process, especially from an energy management standpoint. All that conditioned air that we may not be accounting for, it's all a cost. System effect. How many of you have sat in a job meeting, just with a show of hands, and tried to wrap your head around system effect on a project, and you guys actually came out of the meeting dumber than you went in? Anyone? System effect is so hard to quantify, and actually the process that goes into quantifying system effect, in some cases, the time outweighs the time that we actually bid to balance the entire system, because we're trying to look at what is going on. Is it the elbow off of the discharge, or is it the elbow on the inlet of the fan? And what effect is that having on the brake horsepower and the RPM? Sometimes fans will start to get like a breathing effect if they don't have a good inlet condition. They'll get a big slug of air to come through and it takes a second to pick back up. That's all a version of system effect. And it's very hard to quantify, but it is a real thing that we go through. And it all deals with going back to possibly added elbows. Maybe they got out to the job site and there was a conflict in height between the drawings and the sheet metal and the pipe. So they had to do something different to get that in. Those are the types of changes that take us away from the original design that can have an impact and actually add up to system effect. And there's a great example showing you the rotation and what happens to the airflow. So the airflow is actually coming into the fan that has an elbow right on the inlet of it, and it's having to pull it almost a 360 before it even goes into the fan. I guarantee you that fan's going to work a lot harder to do what it's intended to do, and it's not going to ride on that beautiful AMCA fan curve, right? Oh, and that can be found in the tab journal, spring of 2019, system effect considerations. If you guys ever wanted to grab any of these articles, talk to Ray or Anna. They have all this stuff back at headquarters if you wanted to look into some of these articles. System affected fans. Again, this just kind of highlights some of the things I was talking about as far as inlet or discharge conditions and how they affect it. And here's a really good real-world example. This is an AABC tab firm that was doing a packaged rooftop unit for a retail store. And supposedly, this unit, I will not say who the manufacturer is, was sold 5,000 times across the United States. It was used in multiple locations, and they never had any problems. Except when the AABC contractor came out to this job, the unit was bouncing on the roof, like physically bouncing up and down the roof. And what was happening is, you see right here where they put in this plate? This is an aftermarket feature. This was open in between here, and what was happening was the two fan inlets were starting to fight each other. And they were causing the suction to actually lift this big unit on its curb. It was moving the whole roof. And what the AABC tab firm came in, wrote some very good letters trying to explain to the manufacturer what was happening, and the only response they got was, this unit's fine. It's a package unit. We put them in all over the country. It's an aberration. Let us come out. We're going to show you guys how to balance it. Okay, no problem. Come on out. So we all got together. We got 20 people standing on a roof. It wasn't me. I say we, but I'm saying this as a friend. I know the gentleman who did this. And you got 20 people standing on the roof. We're all standing around, and we're looking at what the manufacturer is going to do to stop this thing from bouncing on the roof. Well, all that money, all that time, everybody's standing up there. By the end of the day, there was still no answer. The manufacturer was now baffled. What do we do next? The ABC contractor's a smart guy. He said, why don't we put in a vortex breaker? Just like if you had a pump. Sometimes you get some cavitation or something going on with the pump. You want to put a vortex breaker in. We just put in this little piece of metal. Broke up the vortex. Guess what happened? The unit's running fine. It's not bouncing. The roof's no longer in danger. People can go back in the building. This was bouncing so bad that they were scared to send people into the building. So again, if you have a really good test and balance firm that you guys can rely on and ask specific questions, this is the added value of a tab firm that really cares about the process and cares about the sustainability and the serviceability of the equipment after they leave. So right here is a perfect example of the AMCA charts showing one thing and the manufacturer saying one thing. And I love the manufacturers, don't get me wrong, but the people that say that they're most certain about something are most certainly wrong sometimes, right? I had some in my experience. So with this, the test and balance firm was able to get the 1750 CFM package rooftop unit back under control, the building open and occupied and ready for service. And all it took was a little vortex breaker. And I still don't know if the manufacturer went back and altered their design. I'd like to think that they did, but I find it hard to believe that this is the only one in the country that was doing that. Pump curves. A lot of the times when we get out to a pump, it's way different than air side. We can drill a hole or we can open up an access door on the duct side, send a camera down the duct, see what's going on for obstructions or anything. On the pump side, it's way harder to troubleshoot. We've got a couple of gauges, maybe a triple duty valve, and then we've got some outlets that we can go down and maybe some zone valves if we're lucky, so that we can kind of back into some of the things we're seeing in a pump. But it's really important when you're choosing a pump for troubleshooting purposes that we get away from this flat curve, right? It's a very, very flat curve. So from here to here, let's say, from a balancing standpoint, I'm looking at anywhere between 200 and 600 GPM. If I've got to take that information back to a job meeting and I say, I don't know, it's going between 200 GPM and 400 GPM according to the chart and the pressure drop, you guys, I'm sure you can imagine what the GC said, you know, like, well, what did I bring you out here for? But it's really not the tab firm that's doing anything wrong. We're just looking at the charts and we're taking our pressures where we can and we're trying to look at what's going on. In this case, I know exactly what's going on because I have a very steep curve. So I can come out here and with my same pressure, I know I'm doing 200. And if I come out here, I know I'm doing 600. And I can look at that very quickly and there's no guessing. I can look at the pressures, I can plot it on here, and it's the question of what GPM I'm actually on is very, very much more narrow. So then we can actually start to look at, is the impeller wrong? Is the motor not sized correctly? What else is going on? But at least I'm able to tell exactly what GPM we're doing on a given point. This is just a good detail. You know, it's to kind of show what we would need or what would be expected for us to find in the field. The detail is the most important thing because if we get out there and the detail didn't show gauges, it didn't show the ability to have a piece plug or anything installed, we have no way of enforcing the fact that the installer did not put it in per the detail. So having a very detailed detail, we're able to hold the installation contractors a lot more responsible. Scheduling challenges, right? This is always the easiest part of our job, right? Getting everybody to work and come in on the deadline. I don't know how many times I've submitted my bid to the GC. He comes back to me and likes the values, gives us the job, and he knows because of my bid that I plan to do 16 weeks worth of balancing on that job because I highlighted it and he wanted everything itemized. So it says right there that I need 16 weeks to do my work. I get to the kickoff meeting and I got 4 weeks to balance on the Gantt chart. Well, what the heck is going on? Like, guys, we talked about this, right? So there needs to be enough time allowed in the schedule for the tab work to actually be completed. And like I said before, whenever there's a delay, the deadline does not get extended. So what happens? The last kids off the bus, commissioners and tab firms, we all have to expedite our work, right? But then they still want it done at a high level. So if we can coordinate at the beginning and really emphasize to the GC that you can't let these dates slip Because if you do, I can't deliver the product that you want. That's really an upfront contract to the GC that, hey, these are hard dates. To do my job correctly and to do it per the spec, I need to have 16 weeks. All work must be complete for a tab work to commence. Believe it or not, we need filters. We have to have them. We got to have strainers. I got to have a balancing damper or I can't do my job. On manual water valves and flow measuring stations, they need to be 100% open. I know from practice that mechanical contractors come in, they install everything. What's the first thing they do? Anyone? Shut a valve, right? They start shutting valves. And then those valves may never be opened again until we get there. So what happens during the flushing process? Doesn't get flushed, right? So it needs to be spelled out that for the tab guy to start, everything's got to be 100% open, including control valves. And we need to have a filled system, right? So we get there and the makeup system isn't even right. It's not even connected. We can see the hose not connected in there. How are you guys doing your makeup? Oh, it's fine. Everything's, well, the hose is on the floor there. We need to know that the system is filled. All these things, all they add up to is delays. If I get there and there's a mechanical guy who's just installed 500 valves and they're all closed on the building and he did his whole flush, and then we walk in and we start reporting that valves are closed, that mechanical guy gets really mad at us because now we've shown to the owner that they didn't do their flush correctly. And that's just something that will come out in these meetings. And I, in the kickoff meeting, whenever we're in there, I give a sheet to the commissioning with the commissioning agent and the GC with an expectation checklist of what is going to be there, what is going to be necessary to be in place for me to do my balancing correctly. So if you guys, looking at the specification from both the commissioning standpoint, because you guys are there way before the tab firms are. You guys are brought on at the prime level. You guys may actually have access to the project documents and for 6 or 7 months before the tab guys actually get there. In some cases, if the tab is controlled by the mechanical, we may get it a couple of weeks before the job because something I see mechanicals do a lot is they wait until the end and then whichever tab firm can get there the fastest is the one they're going to give the job to. And that does not equal a good, well thought out balancing plan when I only have a week or two going into a $60,000 or $70,000 balancing job. I've already missed my chance to give you any added value about what could possibly happen with high velocities in your ductwork because things are sized too small, and the same goes for water. You know, if some of the water valves are too small or too large, if they're oversized, and we're having to close them down to almost close to get the GPM we're looking for, then I could have brought that to everybody's attention at the beginning had I known that and I had access to those documents and knew I had the project. So those are just a couple of things that we really need and some better practices that I think will totally make everything, the project come out better. I got the high sign for 10 minutes, so I'm going to move along here a little bit. Remember that the tab work is completed by HVAC system, not area. We cannot go into the portion of a system and balance 8 of 20 outlets and expect that balance to hold when we come back in to do the next 20. You have to balance an entire system at once. Now that doesn't mean that if it's called out in the phasing of the bid, that the balancer should not have time to rebalance systems as each phase completes. So that's another thing that you would want to do as a better practice is make sure that the tab work is going to be completed by system, not area. Very seldom do HVAC systems match the phased areas. So a lot of the times we go into a phased area of a hospital and there's piecemeal, 3 or 4 air handlers serve one area, and we're trying to figure out how to get that area balanced and the pressure relationships in the corridor. Make sure the owner and the architect understand the possibility that the tab work might be performed after occupancy. This, again, goes into those delays that push us back off of that deadline on the Gantt chart. It's a definite possibility, but if significant balancing has been done and outside airs are set, there's no reason that the balancing can't continue as occupancy starts. Variable volume systems, air and water, can have provisions to balance partial HVAC systems. For phased projects, constant volume systems are much more difficult to address. Obviously, with VAVs, we have a lot more opportunity for fine control. When a constant volume system is rebalanced, We have to get everything in place, and our last pass through the system needs to be a total read, not a read and touch 1 or 2 dampers. We need to be able to go through and read that entire system top to bottom and make no adjustments, in my opinion, for it to be a total system balance. Access challenges, we always know that the service guys in the building, they never are given the time or the attention at the beginning of the job, and a lot of the times we end up with situations like this. How the heck am I going to get my balancing probes on that? Or, worse, why do we have a balancing valve that can spray water in an area where there's an electrical compartment, right? I don't think OSHA would approve. So, really, when you guys are out there starting to do your initial inspections and checklists, a lot of this comes like this from the factory. This is not even the installer's problem because this is a packaged fan coil or a packaged unit. So that was installed like that from the factory. Now what needs to happen is the factory needs to come to the table and pay the mechanical to spin all those. Lastly, why specify AABC? You know, we're the only test and balance organization that adheres to these guiding principles: independence, guaranteed performance, and quality assurance. It's very important that there's some sort of independent police, in my opinion, and I'm a member of a bunch of organizations besides AABC, but I can say as an owner, AABC is my favorite, and I pour more time into that because, in my opinion, the independent voice to the owner or to the commissioner who's going to report to the owner is super important. Mechanicals, there are really good mechanicals out there who balance their own work. I am not trying to knock mechanicals, but there is an inherent bias in someone installing their work, balancing their work, and then nowadays some of them are starting to commission their work as well. And I think that that's a major problem. I don't think that a lot of the problems with sustainability in a building are going to be addressed in that model. Again, that could be my opinion, and maybe I'm over-speaking. In closing, you know, I'd like to say Mechanical Testing, the company that I work for, we're 3rd generation tab firm. We also do some commissioning, clean room testing, ASHRAE 110 testing, sound and vibration, as well as fire and life safety. We're independent from any mechanical contractor, and we're a very proud member of ACG and AABC as well as ASHRAE. At that point, I just want to open it up to any questions. If you guys have any, tangents. Okay, sir?
Yeah, we've got a microphone here so everyone can hear the questions, so I'll pass it around. And here.
Yeah. Any comments on accuracy of outdoor air flow meters?
Sure. Do you mean like in the containers? Okay, yes. I personally like them. I think that if they're calibrated and we're allowed to work with the control guide to get them calibrated, then they're very reliable. To accept that it's factory calibrated and not field calibrated, in my opinion, would be a mistake. It goes back to the same problem as auto balancing valves. They've got auto balancing in the name, but they are not auto verified, right?
I have a 2-part question. First is, how do you simulate system diversity in a VAV air handling system? And then the second one is, what's your views on pressure-independent control valves?
I didn't catch all the second one, so I'll come back to that one. But so for the VAV question, with diversity, what we do is we look at the total flow provided by the air handler, and we'll go and look at the same scheduled values of CFM on the VAV. And then we'll try to pick and choose not everything off of one zone to start to close diversity. And we'll try to simulate the diversity across all the zones. Sometimes we'll get as detailed as looking at what the sun load is on the side of a building, and we'll take the diversity into consideration, and we'll put the building that's in the side of the building in the shade. We'll put that side into the more diverse side and close those down while we balance all of them. But it's a 2 or 3 part question, because not only do you need to make sure that those if there's multiple valves on multiple zones, that you exercise it in at least one condition, but you need to open up those other boxes and close down some other boxes to make sure that that diversity holds underneath a different static dynamic that could be in front of those VAVs.
Good. The second question is, with the trend in going to pressure-independent control valves on the water side, what's your view on how that impacts the balancing and overall system performance?
Well, I don't think it's a negative. I do think that sometimes those valves can make our lives difficult to troubleshoot when we're trying to establish full flow, or we have air in a system and we're trying to send a bunch of water out to push that air that could be lodged out there, sometimes those valves will restrict our ability to do that, but I don't think that there's any negative in having them in the building or the design, and in a lot of cases, they actually help us create the sustainable building.
How would you recommend specifying the balance tolerance for the small diffusers where 5% is less than the tolerance of your instrumentation?
Well, that goes back to specifying and looking at what your intended outcome is.
Right, but what would you recommend? Would you say a 5% or 5 CFM, whichever is greater?
Yeah, I mean, there's a lot of the times where we have those candid conversations around the commissioning table, and it really comes down to two things. One, what's important to the owner, and what's sustainable, right? We want to be able to have those two criteria filled no matter what. To be able to have the owner happy with the product. But it really comes down to the team, and that's a group decision. It's not a decision just for the tab firm. I can give you my opinion, but it doesn't make me right. You can ask my wife that a lot. She'll tell you that I'm wrong a lot. So, you know, in my opinion, it comes down to the team and really what the commissioning is hoping for and then what the owner outcome is.
Brian,
Wish I had a better answer for you, sir. I'm sorry.
Brian, you're well beyond your 20 years. So a question about the example you used, it was early on. Our concern when we have a little area for balancing is the net effect on the rest of the building.
Sure.
Right? So an owner gives us a second floor, basically it's just come into commission, building has been partially occupied, and I've got 9 floors of central air handling unit coming down the pipe. So I ask myself as to, well, what is the effect of doing this floor on other floors? And how do I go about having contingencies for after I touch it as a designer that they're not going to come back and they said, you messed up everything else.
Right.
Right? So I either have to resort to asking for you to check into those through a pre and a post balancing
Right.
activity or something along those lines. So what's your recommendation?
You have to have pre-balance activity going on.
So,
Okay.
so just follow up on that is that then I struggle with the condition change. It's not peak type condition. It's a VAV system, right? So what is that pre-test tells me for us to simulate back after your activities?
Right. So going back to your first question, how do I protect myself from showing that I wrecked the rest of the system, right? That's done through pre-surveys. We've got to go through, and at a minimum, you need to go to those other floors and start taking static pressures on the mains, right? And documenting that all the way down. Because then that gives you a baseline. And to build on that, you need to establish what your base criteria is. Is it simulating cooling? Are we simulating a heating mode? Or what would we want to do there? So there's two things that you want to do there when you do that baseline survey is establish, are we doing that heating load, or is there a diversity we want to build into it? We use the controls to establish that diversity, and then we take our static pressures on the main at a minimum, okay? If that's somebody who's engineered value and they want this done quickly, we'll take the static pressures at those mains. Then when all the work is complete, we'll balance the new area while we monitor the static pressures on those other zones. So that I can then at the end go back to that main after our balance is done and hopefully get the same pressure to serve that zone. And that for me is my get out of jail free card. Because if I had a zone with 12 VAVs on it and I had 1.2 inches of static at the main leading up to those before the process, now I've balanced everything and I've got 1.2 static there. That's a quick way to do it. The real thorough way to do it would be to go through and read all the VAVs and everything off those other systems, but nobody wants to hear that in the budget.
Is there a size that you would recommend if I'm affecting 10% of the building, definitely do this? If it's only 2% of the system?
If it's 2% of the system, we would then really be just monitoring that zone and maybe a discharge pressure. And if we're doing like one soiled utility closet and they're trying to establish a room or switch it from negative to positive, I don't think that there's a way to quantify what percentage is good, but if it's a 2%, I would just be okay with doing that little bit of an area. Also depends on the customer and how picky they are. If they're super picky, then I'm going to say, listen, you know, I need to do all of this verification to make sure I get out of here without you chewing me up.